right, lesson 3, reasoning with angles and triangles, proving angle relationships. We're going to actually rush through some of the beginning and get through some proofs, because this is where we really want to take what we learned last lesson and apply it in a proof. Okay, now constructing a parallel line, I have a little link here. So if, let me just pause this for a sec. I have a link that you can watch and look at. So that link right there will help show you how to construct a parallel line using a ruler and a protractor. So here's that website right here. So you can just click run and it'll begin. And so first thing is we want to take a ruler, pick a point R anywhere, draw a straight line. We take our protractor, doesn't matter where, somewhere between J and R, we make an arc. Then we want that same arc between J, we can call this point right here like C. And really the reasoning behind it, you can see below. What we were doing here is we're making this line the same as that one. And then these, oops, undo. These two right here we're making the same length. This one is already the same because of an isosceles triangle. And then we're on the same parallel lines, right? These two lines, or the JR is the same line. And so here we get corresponding angles, right? And therefore we have parallel lines. And so if you scroll down on this website, you'll see the steps as well as the explanation of why this works and how we can make parallel lines. Okay, so erasing all of this, going back to our notes, the explanation again is all in this part here. Okay, all of this part here. And so we can go through an example of how to do that on the next page. So just a quick question is how are CAD, so angle CAD, how is that related to EBF? And they're corresponding angles, right? And if angles are corresponding, then we know from the previous lesson that the lines must be parallel. So AC is parallel to BF. So, oh, sorry, that goes on the next one. They're corresponding, and what do we know about they are equal? Those angles are equal. Okay, so let's try an example. So I'm going to go through this with you. You're going to need a ruler, and you're going to need a compass. So with a ruler, you want to draw a straight line through P and QR. So there's our straight line. So I want to make sure it's properly through P. We're going to call this point something right here. It doesn't matter what letter. You can call it anything you want. Let's call it A. That makes sense, right? Now this is where my software is kind of limited, but I'll do my best. This is where we need our compass, right? We need our compass. Uh-oh. I have to work with how to use this. Okay, so what we want to do is we're going to take A. I'm going to make this a little smaller. And we want to draw an arc that goes through QR and AR. And you want it to be smaller than, you don't want to go beyond P. And so once we do that, we've just created a line. So if you want, you could even put a dot right here and call this something. So we can call that B, right? And we can call this guy over here C. So now AB, if we take this down and we do the same arc again, just like that, exact same arc. So now we're going to call this down here D. So let's call it D. So PD is the same length of AB, right? Now what we want to do is we want to get, if there's like an imaginary line here, we want that to be the same length on P. So what we need to do is take our compass, we're going to expand it. Now this is what's hard for me because I'm going to have to undo. It's hard to expand this so that I might have to undo first or erase some of my line. So I want it to go through B. So mine doesn't there yet. It's a little too big. So now I'm closer. I can probably move it. Oh, don't want to flip it, but move it. So there I go. So C and B, we have that like there. And so if I were to draw a little bit lower, If I were to draw like that, it goes through B, right? So now we want to take this same arc. I'm going to rotate him. Uh-oh. Be easier to go like that. So if you started at B, right, as well, it would go through C. Now my arc is a little big. There we go. I'm going to erase some of these lines if I can. Can I? Let's move this one out of the way because I don't want to distract you. So, right, same idea here. So BC, that line, we move this down, starting at D. We want to make that same arc. Okay. Now what we have, it's almost like this line is the same as well. So we're going to call that a point. We now have E. And you're going to draw a straight line through P and E. Through P and E. And so what we have here is, if I can just rotate this a bit, these lines should be parallel, exactly parallel. Why? Well, these two are the same, right? And now these are the same, so we have the exact same triangles, so congruent triangles is really what we created. And since A and P are on the same line, right, these are corresponding, therefore they have parallel lines. And so that's how you construct parallel lines. That's how you properly construct parallel lines, using a protractor and a ruler. So not using, or sorry, a compass and a ruler and not using a protractor. So ignore this, let's move on. Remember from last day, we're going to need to use these, we're going to do some proofs. We need to remember a couple theorems. One, if we have a straight line, and we have two angles, whenever two angles add to the same thing, we call them supplementary. So any two angles that add to 180 are supplementary, and therefore on a straight line, two angles on a straight line are supplementary. Vertically opposite angles are equal, so it's like our x property. Vertically opposite angles are equal. And then if two parallel lines are intersected by a transversal, corresponding angles are equal. So two parallel lines with a transversal, the corresponding angles are equal. That's like our f property. So we could say x here is equal to x, or we could say O is equal to O. You could say, we call this Z is equal to Z, or Y is equal to Y. Those are all corresponding angles. Okay, now we also know x and y in that diagram are equal because of vertically opposite angles, but those are the corresponding ones. So proving alternate angles are equal. So here's a proof, okay, that proving alternate angles, remember alternate interior angles are the ones like 1 and 7 and 2 and 8. So if we want to prove that 1 is equal to 7 or that 2 equals 8, okay, so this proof is proving 1 equals 7. And then you would do that, basically the identical thing to prove 2 equals 8. Okay, so here's the proof. Now whenever we have a proof, you're going to have a statement, and then you need to make a reason. So this is where you have to know the names of all the different theorems. So angle 1 equals angle 3. So why does 1 equal 3? What do we call those? Those are vertically opposite angles. So vertically opposite angles. So if I just name the name of the property, that tells us it's equal. Vertically opposite angles are always equal, so we just write that's the reason, vertically opposite angles. Okay, now why is 1 and or 3 and 7 equal? So now they're saying why is 3 and 7 equal? We're going to say those two equal. Well, 3 equals 7, what do we call those? Those are corresponding angles. Corresponding angles. All right, so if 1 is equal to 3 and 3 is equal to 7, what could we deduce? That 1 is equal to 7. Both angles equal to angle 3. So this is that transitive property. You need to know about the transitive property. So you might want to write it on your study sheet or below. Transitive property. So what is the transitive property? It's this. Quite simply. If A equals B and B equals C, then A equals C. Right? That's the transitive property. So here we have 1 equals 3 and 7 equals 3, then 1 must equal to 7. And that's because of the transitive property, and then the reason alternate angles, I mean, then that proves now that these alternate angles are equal. right? And why did we proved it? We didn't actually use actual numbers, right? We just used properties. So it's a proof. If I just did, 50 degrees equals 50 degrees, that's not a proof. We want to prove it for all angles. Okay, so I have a couple extra examples, and we're going to practice doing some proofs. So you always need adjustment and a statement and justification. Okay, so here we have is a cell phone tower, as was built as shown. Use the angle measures to prove that the braces CG, is parallel to BF and AE. Okay, so that's what we want to prove. So remember, if angles are corresponding, then the lines are parallel. Or if there's interior alternate angles, then the lines are parallel. So where should we start? Well, we need to start with either corresponding or alternate interior. So do you see any? There's actually a bunch. So it's up to us where we start. I'm going to start with angle DCG and BAE, because these are on the same line here. Okay, so I'm going to write that out. So how are we going to write that out? So angle DCG equals angle BAE. Angle BAE. And they're both equal to 78 degrees. So what's the justification? Why can I say that they're both equal to 78 degrees? Well, the justification is that it's given. They told us it was. So often, one of our reasons or justifications for saying something is that it's given. And just because it's given doesn't mean in a proof it's important that those are given and that they're both equal, and so we have to state it in our proof. So angle DCG equals B. So what does that mean? Well, if they're both equal and they're both on the line DA, that means that CG is parallel. CG is parallel, that's a symbol for parallel, to AE. Why? Because what were those angles called? What was 78 and 78? They're corresponding angles. So remember, if lines are parallel, corresponding angles are equal. And if corresponding angles are equal, then the lines are parallel. Corresponding angles. Okay, so we proved that CG is parallel to AE. Now I want to prove that BF is parallel to AE. BF. So what is the relationship between BF and AE that we can use? And right here, what do we call angles? Those are alternate interior angles, right? So I'm going to say angle FBC equals angle BEA, which equals 22 degrees. And that was given. They told us that. And so since those are equal to each other, we can say that BF is parallel to AE. And why? Well, because we had equal interior alternate angles, or alternate interior angles. So when our alternate interior angles are equal, then the lines are parallel. Okay, so here we have CG is parallel to AE and BF is parallel to AE. So then what can we conclude about CG and BF? Well, then they must be parallel to each other. And why is that? That's what property is that? That's a transitive property. So there's our proof. There's more than one way to prove this, but this is just one way. So we've finished our proof, and so we've shown that CG is parallel to AE, which is parallel to BF. That's what we proved, okay, in our proof. Let's try another proof. Oh, just so you know, I just want to show you a video to go through this one before we move on. So just another explanation I have here. So the exact same proof. Oh, let's turn the volume up.
From the strategy used in example 3.
There you go.
I needed to use a strategy that was different from the strategy used in example 3 to prove that CG, BF, and AE are parallel. I can think of DA as a transversal for line CG and AE. In the diagram, I could see that angle DCG equals angle BAE because they both measure 78 degrees. Angle DCG and angle BAE are corresponding angles. Since they are equal, the lines CG and AE are parallel. I could also see in the diagram that angle FBE equals angle BEA because they both measure 22 degrees. Here the transversal is BE. Angle FBE and angle BEA are alternate interior angles. Since they are equal, the lines BF and AE are parallel. Since CG and BF are both parallel to AE, all three lines are parallel to each other. Therefore, the three braces are parallel.
All right. So hopefully that helps that one. So given that triangle FOX is an isosceles triangle, angle FOX is equal to angle FRS. Okay, I'm just going to mark that on my sheet so I know. And angle FXO is equal to FPQ. Okay. So we want to prove that PQ is parallel to SR. PQ is parallel to SR as well as SR is parallel to XO. Okay, so where are we going to start? Well, let's start with our given, right? That they told us that FOX is equal to angle FRS. So we can say that was given. They told us that those two, the red ones there, are equal to each other. And what do we call those angles? We call those, it's like the F symbol, corresponding. And so since they're corresponding angles, then we know that the lines are parallel. So SR is parallel to XO. Why? Because they are corresponding angles. Corresponding angles. So same idea for the other side. They tell us that angle FXO is equal to angle FPQ. That was given. So if those two are equal, then what can we say about line PQ and line XO? They'd have to be parallel, because what are P and X? They are corresponding angles as well. Corresponding angles. And so last, if SR is parallel to XO and PQ is parallel to XO, then what can we say about SR and PQ? Then they also are parallel, and what do we call that property? It's called the transitive property. And there we go, we're done our proof. So we've proved both that PQ is parallel to SR and that SR is parallel to XO. It's in our proof. Okay, so you have to have your statement and your justification. So some key ideas here again. Corresponding angles are equal, alternate interior angles are equal, alternate exterior angles are equal. So we didn't really talk about that one yet. So alternate exterior angles like B and G would be alternate exterior angles. Those are equal. And A and H, alternate exterior angles. Whereas the interior ones, alternate interior are equal, D and E. And C and F, I should use a different color. Is another example of alternate interior. Okay, those are equal. And then, of course, E and F would be supplementary. It's an example of supplementary angles because they add to 180. Or E and G are supplementary, G and H are supplementary because they all add to 180. So just some things you need to remember and need to know. So one last example. So prove, complete the following two-column proof. And you should probably try this on your own, pause the video, and then see if you're right. Prove that co-interior angles are supplementary. So I want to, for example, prove 1 plus 4 is going to equal to 180 degrees. So they start the proof for us. They say 1 plus 2 equals 180. And why is that? What type of angle is that? It's a straight angle. Straight angle. So 1 plus 2. And we know 2 equals 4. Why do we know? What do we call 2 and 4? They are alternate interior angles. Alternate interior angles. And alternate interior angles are equal. So if we know 1 plus 2 equals 180 and angle 2 is equal to 4, then what can we replace? We can replace in our proof, so we can change that to angle 1 plus angle 4 equals 180 degrees. Right? And why did we do that? We did that since angle 2 equals angle 4. It's almost like a transitive property. And so what do we prove? Yes, we proved it. So therefore, co-interior angles are supplementary. Okay, so homework for this assignment are numbers 3 to 8. If you'd like to try numbers 1 and 2, you're more than welcome to. But if you need extra, I do have extra practice for proofs if you need more after this assignment is done.